Alright, so today's lesson is going to be on rocks providing a timeline for the Earth. So we're going to figure out how we can figure out the age of rocks through some basic geological principles. And the first thing I want you to do is just take a look at these three beautiful children here and think about what you can tell me about the ages of these children. So what can you tell just from the picture about their ages? You probably can't tell exactly what their ages are. You might have a guess based on some clues from the picture, but you wouldn't be able to, for sure, know exactly how old they are. However, you could probably look at the picture and tell me that Kenan over here on the left is probably the oldest, Aiden on the right is the youngest, and Aubrey is somewhere in the middle. The same is true for these three televisions. You wouldn't necessarily know what year they were made in, but you could look at the the TVs and tell me that this one was the oldest, this one was the newest, and this TV was somewhere in the middle. Well, that's what geologists do with rocks also. They look at the rocks and they figure out the relative age, which is the age of a rock compared to the rocks around it. And they're not giving you an exact age, an absolute age of the rocks. They're just telling you the order that the rocks were deposited in. They use words like older or younger. They're giving you the age of the object, the age of the event, the age of the layer in relation to. That's where they get the word relative to. It's relative to the other things around it. So, again, relative dating is going to tell us the order that the events happened in, but not exactly when. So here from the picture, I can tell that layer A was deposited first, and then layer B, and then layer C, D, and then E. The youngest layer is at the top. I don't know exactly when they were deposited and formed, but I know which one was first, down here, layer A, and which one was last. I know the order. That's the relative age. Now, how are you going to figure out the relative age? Well, there's a few principles that guide geologists in figuring out the relative age of rock layers and of different geologic events. The first principle is going to be a big old long, really fancy sounding science term. If you can spell it, you can say it, you're going to look really smart. It's called the principle of uniformitarianism. And that's a really big fancy sounding word that just means not what it says here on the screen. That is the wrong information. It's supposed to say it means that the forces that are acting on the Earth today are the same forces that were acting on the Earth in the past. So we make the assumption that the way the world works now is the same way that it worked in the past. The second rule is going to be the principle of original horizontality. And again, it's a big fancy sounding word. What it means is that we know that sedimentary layers are originally deposited in horizontal flat layers. If you go out and you see layers that aren't horizontal, something has happened to them. Something has deformed them or changed them because of movements in the Earth's crust. So we talked last chapter about plate tectonics and how the plates are moving. And so those layers of sedimentary rock that get deposited in flat, horizontal layers will sometimes get bent. They'll get cracked and moved. They'll get even flipped over on top of each other. But the idea is that when they're deposited, they don't get deposited standing up. They don't get deposited flipped over. They get deposited in flat layers, and then something else happens to deform them. The third law is going to be the law of superposition. And again, another big old fancy sounding name for the idea that the oldest rock is going to be on the bottom and the youngest rock is going to be on the top. So if you have an undisturbed layer of sedimentary rock, an undisturbed sequence, we can say, okay, all of this sediment was deposited first in layer A, then layer B got deposited, then layer C, and then layer D. And so that's just general. We know that those things are going to be deposited in that order, and that's the law of superposition. So you can see here in the Grand Canyon's history, Here's a pretty picture of the Grand Canyon. Here are the different rock layers that were deposited. And the law of superposition tells us that this limestone layer is the youngest. And this layer, the Supai group, is the oldest. So it goes younger as you go up, as long as nothing has happened to disturb the layers. However, as we said before, there's tectonic plates that are moving. The rock is not just staying where it is after those sedimentary layers get deposited. So things can happen. The layers can get turned, they can get bent, they can get folded over, they can get broken. And when this happens, we call those layers disturbed layers. It just means they're not in their nice, flat, horizontal layers anymore. Something has happened here to disturb these layers and to make them stand up. Here, something has happened to deform or bend these layers. Another example, these layers have been bent up, and then part of them have been eroded and worn away. Another example would be a fault. So here you can see that when the layers were deposited, they were all deposited in one straight layer. But then, because of tectonic forces acting on the layers, they were broken and separated. So this white layer here that was all one layer has gotten separated by a crack in the Earth's crust. You can also get things like intrusions, and an intrusion is where magma squeezes into the existing rock and it cools. So here's our definition of intrusion. And this is actually a layer that is an intrusion. It's magma that's worked its way in there and made an igneous intrusion into the rock. You can have, as we said, faults that are breaking the rocks. And if you have these things happening, the intrusions and the faults, things that cut through the layers and affect the layers, are always going to be younger than the rock layers they affect. Because the rock layers had to be there, they all had to be there before they could get cracked. So that's going to be our next principle, and that's called the principle of cross-cutting. And so the principle of cross-cutting says that geological features, such as faults, such as igneous intrusions, are going to be younger than the rocks that they cut. So here, our principle of superposition says that layer C is going to be the oldest because it's on the bottom, and then we're going to have E deposited, and then D, and then B. That's hard to do. And then our last one is going to be A, because this is an igneous intrusion. This is magma that has come up through the layers and then spread out here. But it's affected all four of these layers. And so our principle of cross-cutting says the cross-cutting feature is younger than any layers that it affects. So A is going to be our youngest layer. All right, so again, geologists are going to assume that sediment's deposited in horizontal layers, and if it's not horizontal, then it must have been disturbed in some way. It might have been tilted, it might have been folded, it might have an intrusion, it might have a fault, but those things that have changed it are younger than the rock layers that it affects. So we're going to do a little bit of practice with identifying the different layers from oldest to youngest. So here, looking at this diagram, we're going to see that E is on the bottom, and so it was deposited first. Then, it's tempting to say that C was next, but actually B happened after that because it affected layer E. Then we have some erosion, so this is showing that some of the layer was eroded and worn away. And then on top of that uneven surface, we had C being deposited, then layer D, and then layer A. Let's try another one. Here you're going to find a map symbol over on the side to show you what's the type of rock. When you do your practice problems at the end of your notes, you'll have a key for that as well. So here again, we're going to say, okay, the first layer that was deposited is going to be on the bottom, which is limestone. And then we had the next layer of sandstone being deposited, followed by the shale, and then followed by the faulting. Now again, we know the faulting happened last after all of these layers because it's going to be younger than the layers it affects, and it affected all 3 layers. One more practice problem. Okay, here we go. We've got our first layer that is being deposited is going to be the limestone again, then the sandstone, layer 2. Layer 3 is the shale. And then all of them are folded and bent, got tilted, so that's going to be our last or youngest event. Because it affects all 3 layers, that means it's younger than all 3 layers. All right, we are not going to do index fossils yet. You can go ahead and do the practice problems on your notes page.